So today we are going to look at parallel lines, transversals, and the angles that are formed by those two things. So parallel lines, you guys know already. Parallel lines are those two lines that never intersect. They look a little bit like this. They're never going to intersect. They're going to go on forever and ever. What we're learning today is a transversal, and transversal is a line that cuts through those two parallel lines. Of course, here, this purple line, that's going to be your transversal. They don't always look like this. Sometimes the parallel lines can be straight up and down, transversal across. Sometimes there's more than one parallel or two parallel lines, one transversal. Sometimes there's two parallel lines and you could have more than one transversal. Either way, the transversal will cut through these parallel lines. So let's take a look at these angles that are formed by them. So our alternate interior angles, and for all of these, the names are actually pretty self-explanatory. In this case, alternate, we could say alternate means opposite. And interior, of course, that means inside. So if you're wondering where to find these angles, you have to look at the inside and on opposite sides. Make little bullet points. So next to alternate interior, I do want you guys to write where you can find them. That is between the parallel lines and on opposite sides of the transversal. You are going to need a couple different color pencils. If you are in my room, they're in the back table. If you're at home, well, pause this video and go grab them. So yeah, between the parallel lines, these two are my parallel lines. Of course, this one here is the transversal because it is cutting through them. And I'm going to draw in all of my angles on the interior, aka on the inside. That's not the only requirement. The other requirement is for them to be on opposite sides of the transversal. So for example, we're talking about angle 3. We take on the transversal, hop on the other side. The opposite of that angle would be angle 6. So those two are actually congruent. What that means is, let's say angle 3 measures 100 degrees. Angle 6 measures 100 degrees. Same thing for angle 4. It's on the inside. If I hop on to the other side of the transversal, angle 5 is the congruent angle. So an example for the notation here, you could say angle 4 is congruent to angle 5. And so if alternate interior meant opposite and on the inside, alternate exterior is opposite and outside. So here for the bullet points here, you could say outside the parallel lines. And opposite sides of the transversal still. So this time I'm going to draw in all my outside angles, angle 1, angle 2, angle 7, and angle 8. Same thing still applies. They have to be on opposite sides of the transversal. So in this case, I would say angle 1. Hop on down the transversal and to the other side, that would be angle 8. And then angle 2, hop down the other side of the transversal, and angle 7. So for these, you could say angle 1 is congruent to angle 8. Outside the parallel lines and opposite sides of the transversal. Corresponding angles is one that a lot of people have trouble with. In corresponding angles, the bullet points here are actually same side of the transversal and in the same position. And so here, the way I like to see it is I imagine I pick up one of my parallel lines. So for example, I say I pick up this parallel line, lay it on top of this bottom parallel line. The angles that are overlapping, those are going to be the corresponding angles. So for example, if we did that, if we picked up this top parallel line, laid it on top of this bottom one, angle 1 and angle 5 would be directly on top of each other. They would be overlapping, as well as angle 3 and angle 7, angle 2, angle 6, angle 4 would be on top of angle 8. But if that is a little bit too difficult for you, you could just say same side of the transversal. Did I spell transversal wrong? I sure did. Write transversal properly on your paper. But where was I? So yeah, same side of the transversal. So we're only looking at the ones on the same side of the transversal, but in the same position. So here I see angle 1 is on the left side of my transversal and on top of another angle. So I look down here, angle 5 is also in the left and on top of another angle. Same thing for 3, left side of the transversal underneath an angle. Angle 7 is also on the left underneath an angle. But again, you could just picture them both of those ways, whether overlapping or in the same position, you'll get your corresponding angles. For same side interior angles, I do want you guys to make a note. This is also called consecutive angles. They mean the exact same thing, just different textbooks and whatnot have different names for the exact same angles. So on your homework, it might say consecutive. On your test, it might say same side. Just really depends on who's writing it. So in same side, self-explanatory. Interior still means inside. So I am going to go ahead and draw in all my interior angles, all the ones between the parallel lines. But of course, if it says same side, they're going to be in the inside and in the same side of the transversal. For example, here we have angle 3 and angle 5. Both of those are interior and on the same side, as well as 6 and 4. Self-explanatory, same side interior. Don't forget, they might be called consecutive on your paper. Let's move on to our last two, our vertical angles. Vertical angles are across from each other. And they also form an X. What I mean by form an X is if you take one parallel line, one of the parallel lines, and it's transversal, then you have sort of an X thing going on. So if you get all those angles touched by that X, the ones directly across from each other are going to be the vertical angles. So for example, angle 1, the one across from it is angle 4. And then angle 2, the one across from angle 2 is of course angle 3. And these X's can be found pretty much anywhere as long as you have one parallel line, one transversal. So in this case, you would say that, for example, angle 6 and angle 7, and you could say angle 5 and angle 8. Those are congruent from to each other because they're vertical angles. Supplementary angles have a sum of 180 degrees, which means, of course, that if you add both of those angles, they will end up being 180 degrees. These also form linear pairs, aka a straight line. So for this example, there's actually quite a few all over this diagram. But what I like to look at is what two angles put together will give me one straight line at the bottom. So for example, if we take angle 1 and angle 2 they form a straight line going this way. If I am looking, for example, at angle 2 and angle 4, those form a straight line. We're talking about angle 5 and angle 6. Here's a straight line there. We're talking about 3 and 5. We have straight line there. All of those are supplementary angles. And again, there's more than the ones that I highlighted. Just keep in mind, if they form a straight line, they will add up to 180 degrees. So for example, if we said angle 1 measured 80 degrees, and they asked me to find the measure of angle 2, well, that's real easy because they do form a straight line here. So I know they have to add up to 180. So this is already 80 degrees. This has to be 100. Of course, added up is 180. Same thing, for example, if we say angle 6 and angle 8, if we say angle 8 is 20 degrees, then we would know that this angle here would be 160. Angle 6 would be 160 because added up, they do equal 180 degrees. So for here, the notation, you could say angle 1 plus angle 2 has to equal 180 degrees. So that's it for our angles. If you have any questions about these, please pop into B Lunch Monday through Wednesday and we can get your questions answered.